On today's video, we're going to talk about ethers. Ethers are a new functional group, a new family, that's characterized by having a central oxygen atom that's dividing two different carbon chain radicals attached to this oxygen atom. Remember, oxygen can only make two bonds, so we're separating two different things. Here in this case, when we talk about the classification of ethers, we can speak about ethers which are aliphatic, which means that both of the branches that are attached are not aromatic. That means they're not derived from benzene compounds. Aromatic ethers are two chains where both of the compounds are aromatic, not necessarily benzene or not necessarily phenyl in this case. They can have other branches attached to them, but they are derived from aromatic compounds which are benzene based. Or a mixed ether, which can have one of the branches as aromatic and the other branch is aliphatic, even if it's cyclical. Regarding the other classification, we have to look at what's attached to the oxygen atom. In this case, when both of the chains are the same chain, this ether is said to be symmetrical. Symmetric. This ether, we have the exact same group attached to it, so it's also a symmetric ether. On the other hand, this last mixed ether is different. It is different what we have on the left side and what's on the right side. So this one is asymmetrical. It's that simple. Let's do another example. I'm going to draw another one here. And we can have this shape right here. And on this side we have this shape, right? So both of these shapes are different. So this ether is also asymmetrical. So we can have basically all different combinations of these two different types of classification. Classification based on the type of chains that are attached. In this case, this ether is also aliphatic. Or we can have the other classification based on if the groups that are attached to our oxygen atom are the same in the case of symmetrical ethers or different in the case of asymmetrical ethers. When we speak about nomenclature, we're going to talk about something very simple, which is the common naming of ethers. Common names. So common names are when we identify exactly what's very simple that shows up. So we're going to name the alkyl group that's attached, the other alkyl group that's attached, plus the word literally ether. In this case, in this first example, we have ethyl. And here we have ethyl as well. So, since there's two of them, like in other exercises, we're going to say diethyl ether. So, both alkyl groups plus the word ether. Then, in this case, remember benzene, when it loses one of its hydrogen atoms to become bonding, it's called phenyl. So here we have phenyl. On the other side we have phenyl. So then this exercise is diphenyl ether. In this case, however, we have phenyl again. And on the right side of the oxygen we have isopropyl. So using different styles of naming, here we're using purely alphabetical. P and P, PR, PH. Phenyl goes first, so in this case, phenyl, isopropyl, ether. Make sure you consult your teacher. Some teachers teach it with a different order. Some people might not ask you to hyphen isopropyl. I do. But in this case, remember to ask your teacher about the order, but this should be pretty much the same. In this case, phenyl, isopropyl, ether in a purely alphabetical order. In this case, let's look at the branches that we have. 1, 2, 3, 4 attached in what type of manner? In a straight line. So this is N-butyl. And in this case, we have 1, 2, 3, 4 ending in an antenna shape. This is isobutyl. So since we have two types of butyl here, we do use a prefix in this case. So here we're going to write isobutyl, N-butyl, ether. And again, this is for common names, which I'm writing again just to emphasize what we're going to do here, which is the common names. You can look at the other video that has been uploaded on naming others using UPAC.